Okay, so today we are discussing this particular problem, 2780. Here we have to find the minimum index of valid split, right? So I hope you have read the question, but just to give a summary of that, is that we have given one array, right? There will be one array that is given, right? And in this array, there will be one dominant value, right? Let's say it's dom, okay? Now this dominant value will be the count of this dominant value will be greater than if n is a number of element in the array, it should be greater than n by 2, or we can say it is greater than equal to n by 2 plus 1, right? Because that is the minimum value that it can have, and the count of dom will be greater than that, and we are guaranteed that there is one dominant element that is present. Okay. Now what we need to do in the question is that we have to split this array into two parts, right? And we have to find out that the dominant value in this particular subpart is equal to whether is a dominant value in this subpart, right? So to formally say what we are doing is that this is an array, right? So let's say this is a one partition that I am doing, and let's say this is it has a k element, right? So how many element it will have, right? It will have n minus k element, right? Because total elements are n, and if I have in my left subpart k element, then it has a n minus k elements are on my right subpart, right? Now what I want is my dominant value in this k element should be equal to my dominant value in this n minus k element. Okay. So the dominant value in this k element is, we call it as what we call, let's say it is a ak, right? Ak is a dominant value in first k element, right? So by definition we should know it should be greater than equal to k by 2 plus 1. Why? Because there are k element, and for ak to be dominant, its count should be greater than equal to k by 2 plus 1. Similarly, and we also want this AK, right? This AK should be present in this as well, isn't it? So what we want AK, right, to be greater than equal to n minus k by 2, right, plus 1. Okay, we also want that, isn't it? We want the AK dominant value that is present, and it should be greater than equal to k by 2 plus 1, right? Because that is what a dominant condition is, right? And in in the right subpart, our AK should also be greater than equal to n minus k plus 2. Now, since we know, if since this is a mutually exclusive event, right? This is a mutually exclusive, this is a mutually exclusive. So what we can say is that in the right subpart, AK, if AK is greater than equal to this, and in the left subpart, and in the right subpart, if it is greater than equal to n minus k by 2 plus 1. So in all the array, right, in whole array, we can write AK, the count of AK should be greater than equal to sum of these two values, right? Isn't it? K by 2 plus 1, because it should be greater than this, plus it should also be greater than this in the right subpart, right? Because in the right subpart, we can also add this guy, right? Okay. Now we can see we can cancel out this k by 2 and this minus k by 2, right? And so what it will become? It will become the count of AK should be greater than equal to n by 2 plus 1 plus 1 is 2, right? So the value, right? So what we have actually deduced is that we did a partition, and we say ki if the dominant value in this left subpart is AK, and it should also be the dominant value in this right subpart. So in a left subpart, it should be greater than equal to this. In a right subpart, it should be greater than equal to this. Taking whole array as a whole, right? All array as a whole, then it should be greater than equal to this particular sub, right? This plus this. And we cancel out this, and we say, ki, okay, AK, our AK should have this much number of elements, right? Now, since we know, right? Since we know we have a DOM value, right? Our DOM value will be greater than equal to this. And since this is a dominant value, right, in the all the array, right, and if suppose if some value has this greater than equal to n by 2 plus 1 element, so there are no any other element that has a this much capability, this much number of elements, right? So we can say that ak, right, should be equal to dom. Okay, why? Because ak has to be greater than equal to n by 2 plus 2, and there is only one element which is greater than n by 2 plus 1. There are all the other elements are less than half, right? The count of them is less than half. So AK should be dominant value. Otherwise, we cannot actually able to achieve this kind of condition. Okay. So what we are now, the problem is very much simplified. So if we are able to find the dominant value in this particular array, right? So what we can do, we can maybe find out its occurrence in this left subpart, its occurrence in this right subpart, right? And the occurrences should be holding these conditions, right? The occurrences should be holding it should be dominant in this left subpart also, in this right subpart also. But we have just proved that this is the AK is the only guy which can make this condition true, right? If I am dividing it k and n minus k, then AK is the one which can make this condition true, and AK is nothing but a dominant guy. Okay, and AK has to be the dominant guy, otherwise it is not possible for any other element apart from dominant person to be uh, holding this condition, right? To be able to hold this condition. Okay, so now condition is very much simple. Now if we are able to find this the dominant value in this particular array, then we want to find ki how many times it has occurred in this left subpart, how many times it has occurred in this right subpart, and whether the occurrences in the left and right subpart are dominant or not. The moment we find out, the moment we are done, right? So the first part is to find a dominant, right? Okay, that is how we reach the dominant part. How do we find the dominant in an array? Obviously, there is a hash map approach. Ki you can, put everything in a hash map and then you can iterate with the keys which have a higher occurrences or which have a higher frequency. You can take that up. But we have a better approach, and that is what we call it as a Moore's algorithm, right? Moore's algorithm, what Moore algorithm do? Moore algorithm is basically going to take this fact into account. It will say, okay, I will iterate all the elements, right? And what I will see, I will maintain two variables, right? First variable is a last seen variable, right? And second variable is the last seen variables count, okay? The count of the last seen variable, okay? So what we will do, for example, just to dry run, we will say the last seen variable initially is -1. Then we see 1, right? So our last seen variable become 1. Then we go to 2. So our last seen variable become 2. Okay. So on. So last seen variable is just nothing but a previous element. Okay. Key, what is my previous element? And the count variable is nothing but a count of that last seen variable. Okay. So if the last seen variable is nothing but equal, right? If the last seen variable is equal to my current element, we will say we will increment that count. Otherwise, we will decrement that count. Okay, let's quickly run this example, right? So we have 1, 2, 2, 2. Okay. So initially, last seen variable is equal to -1. Okay. We come to this position. Okay. So my last seen variable become 1 and my count becomes 1. Okay. Then we come to 2. Now my last seen variable is 1. So my last in will element value is also not equal to my previous value, right? So my count will not increment, and I will update my last in variable as 2. And it has occurred one time, so we will be maintaining one variable. Okay. Then we move to the second value. Okay. Now the second value, last in variable is 2, right? And I am also, encountering 2. So my last in variables count will be 2, comma 2. Yeah, because 2 has occurred 2 times in a row. Okay. Then we come to this. We also see the last in variable is 2. So we go to 2 and we are going to increment the last in variable will also become 2. and its count will become 3. At the end of the story, whatever is the last in variable, that is my dominant guy, right? That is how the algorithm works. Algorithm works in a way that if there is a one element, right, there is one element which is greater than n by 2 plus 1. So we will be doing plus 1 plus 1 plus 1 at least for n by 2 plus 1 time, right? And because we are doing this plus 1, right, this plus 1 is very much important because if it would have been n by 2, right, if the dominant value are occurring n by 2 times, then it could have been cancelled out by n by 2 times also, right? But because we have one more than the half the element, right? So the rest of the element will not going to have this much element, right? Maximum the rest of the element will have is n by 2 minus 1. Okay, this is the maximum the all the other elements can make the sum, and this guy can make this sum. So if you subtract that out also, because this will be minus doing subtraction and this will be incrementing. So even if you do that, there will be at least one value that will remain in the Moore algorithm, and that will say it is my dominant, right? So whatever is the last seen variable, that is what our dominant value is. Once we are able to find out the dominant value, right, we will find its count, right? What are the total number of dominant values are present in this, right? Essentially, if we are finding out the count of dominant values, okay. So once we are able to find dominant value, the next step would be to find the count of dominant value, okay. And you can easily do that with the one, if because if you know the dominant value is, let's say, 2, then you will again iterate from start, right? And you will see how many 2s are present. So that will give you the count of dominant value. Why we are doing this count of dominant value? Because we want to make sure that this condition is holding true. See, at the end, let's say I have a count of dominant value. How it will going to work? We are again going to iterate and see, right? The moment I get the dominant value, this is the where my partition can happen. Okay. Now I want to see how many of the dominant values are present in this and how many are present in this. So if if I am moving from this direction, I can keep on accumulating the count, right? So I will be able to know what is the present count in the left subpart, but I will not be able to know what will be it present in a right subpart. So to do that in O of one time, if the count of dominant value in this is less, let's say x, right? And total count is y. So here the count will be y minus x, right? Because the total minus whatever the count that you have already encountered, that will be nothing but present in a right subpart. So that is why we are finding out the total count, right? To find out the number of values, number of dominant values in this right subpart. And we can do that because we can, if we are sweeping from left, right, we know ki x is a number till now, x is a dominant number of dominant values. So we can know that the right subpart dominant values also, right? And once we know that, we just need to see ki whether this count, right, if it is x, right, it is dominant or not. And also whether y minus x that is present and that is present in the left subpart or right subpart is dominant in its right subpart is or not, right? And we can do that by simply checking this condition. If a by k, right? If k is a number of elements that are present in left subpart and x is the dominant values count in the left subpart, so x should be greater than equal to k by 2 plus 1, isn't it? That is why it makes x as a dominant value, right? X is a count. Similarly, if y minus x is a count and there are n minus k elements in this, so y minus x should be greater than equal to n minus k by 2 because this is a number of element in the right subpart and this is a number of element of the dominant value in the right subpart. So the dominant value should be greater than equal to it's more than half of this guy, right? And that is how you will be able to reduce it, right? So code is also very much simple. So just to summarize what we have done. So we were given this question. We were given that there is a one dominant value. That is a very good trick. If there is one dominant value, we know that it should be greater than equal to n by 2 plus 1. Then we want to partition this array into two parts, left and right part. And we want the same dominant value in this two left and right subpart. So what we did, we see ki, let's say AK is a dominant value in left subpart. So it should be greater than equal to k by 2 plus 1. It should be, and AK also has to be greater than equal to n minus k by 2 plus 1, right? AK is nothing but a count of the dominant value. And if we see the AK, right, AK, the count of total, because these are mutually exclusive events, we can add it. So the total count of AK, right, should be equal to nothing but should be greater than equal to n by 2 plus 1. And because the question is stating there is only one dominant value and which has a occurrences like n by more than n by 2 plus 1, then we can say ki AK is nothing but our dominant value, right? Which is present in the array, right? So, so whatever is the element, right, which is dominant in left subpart and right subpart, there is only one candidate for that, and that candidate is nothing but a dominant value in all the array, right? In overall array, what is a dominant value? That will be nothing but a dominant value in this x and y, because that has only the capability, and no other element has a capability of doing that. Okay, now the question is very much simple now, because now if we are able to find out the dominant value, we will be able to find its count in the left subpart and also in right subpart. And if we are able to do that, we just need to make sure whether it is dominant or not. The moment we get both the right and left subpart, the count of dominant value is dominant, right? We are done, right? That is what we do. To finding out dominant value, we use Moore algorithm. Moore algorithm states because work on the basis of this condition. If there is one dominant value which is greater than n by 2 plus 1, we would have been incremented n by 2 plus 1, right? And there will be, if another values are there, it would have been decremented. And because it is greater than n by 2 plus 1, right? This 1 will at least be present, right? So whatever is the last seen value in the Moore's algorithm, that will be nothing but our dominant value, right? And once we get a dominant value, we will again iterate to this loop or this array to find out the count. Why we are finding the count? We are finding the count because we will be able to know what is the count in the right subpart. If we know if we are sweeping from left and we know till this point, this is x is the number of element of dominant value, right? So we know and we also know why. So we will be able to reduce how many elements are present in a right subpart. And if we are able to know, then we will be able to check the dominant condition. Okay. The code is also very much simple, right? This is a code. Firstly, we are able to see if the current value is not equal to DOM, right? The last value. So we will be updating the last seen value, right? Otherwise, we are incrementing its count, right? And once we are able to do, we are able to get DOM, right? DOM will be having the dominant value. So we find the count of dominating value, right? And this count will be representing how many total dominant value are present in all the array, right? In all the array, we have this count. And afterwards, we just need to do a split, right? One by one, we have to do a split. And we will only be doing split when this guy is dominant, right? And whenever this guy is dominant, we will be firstly updating its count. That left is now containing temp count, right? And my right will be containing nothing but count minus temp count, right? Because temp count is nothing but left subpart, and count minus temp count is nothing but right subpart. So we know how this is the number of element in the of dominant values in the left subarray. This is in the right subarray. Now these should, if this is possible, right? If this is possible, if they are dominant, right? Because I is a zero-based indexing, so I plus 1 is nothing but k, right? Because this is the number of element in a left subpart. And similarly, I plus 1 will be in a right n minus I plus 1, which is nothing but n minus I minus 1, right? This will be in a right subpart. So if this count is dominant and also in right subpart also it is dominant, then we simply return I, right? And that is where our first break will happen. Okay. Otherwise, if we are not able to do, we will be returning minus 1. Okay. So this is the whole question. I think important important pattern in this is analyzing if there is a one dominant value, and dominant value will be this, and then this thing, right? These things are very much important to analyze. If you are able to analyze it, then it is like very much simple. You will partition it and you know the total count. So you will be able to know what is a count in this, and whether it is a dominant or not. Okay, hopefully you are able to understand it. So thank you, right?